Hey everybody, this is Larry. This is day 3 of the October Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem. Yesterday I did a spiel about working hard and stuff, so if you didn't watch that video, watch it. I think maybe I need to label it a little bit differently by naming it after the problem, which is rank transform of the array. Today I just rested a lot. And yesterday's thing, I talked about how to discover things about yourself and what I did, and a couple of interesting stories. I don't know if it's interesting enough, but yeah, let me know if you do watch that video. But today, I'm rested a lot, slept enough. It's a rest day. I forced myself to do no work. I usually walk about 10-15 miles a day. Today I only did about a mile, like intentional, maybe 2 miles. Something like that, just to go shopping, but grocery shopping. So yeah, so I'm a little bit refreshed. So we'll do this problem, we'll do another problem afterwards. Stay tuned for that. And yeah, let me drink this. You know, they should pay me or something, you know, like for advertisement, because I feel like that's all I drink on stream. But I think there's too much caffeine here or something, or maybe I just drink too much of it. Because I feel like yesterday I did have trouble going to sleep because I don't know, maybe too much, either too much sugar, too much caffeine, I don't know. But either way. Oh. Hope everyone's having a great week. Great beginning of the month. 25 days to marathon. So I'm ready to suffer a little bit more. Alright, let's go. Let's take a look at today's problem. 1590. Make sum divisible by p. Given an array of positive integer numbers, return the smallest subarray, possibly empty, such that the sum of the remaining element is divisible by p. It is not allowed to remove the entire array. I guess that's fair. Okay. So, I mean, I think, let me bring up the drawing thing. So, basically, let me find it. Let me put it up. So, I mean, I think there are a lot of these things, right? And I don't quite 100% know the answer to this one yet, honestly. But let's say you have an array, right? And I always think about, for these problems for subarray, I just think about an array as like a list of things, right? So you have like, I don't know, 2, 3, 5, 1, I don't know, whatever, right? Doesn't really matter. And then here, when you want to remove, what does this mean, right? Like when you're just trying to remove a chunk, what is it? There are a couple of ways you can think about this, right? Well, one is that you just kind of brute force remove, which we certainly can, right? And we can do the math that way. Maybe we'll try to do that way anyway. But these are the things that I want people to think about, and think about not just in terms of problem solving, because even if you could solve a problem in a certain way, sometimes it's complicated to implement. And these are things that when you get better and better, you have to balance these things as well, and you have to balance these things sometimes as fast as you can, right? Because in competitive anyway, how much time you spend on something matters as well, right? Yeah, like for me, that's one thing that I've been kind of gotten worse at actually over the years of doing Leetcode, is because I've just gotten, I don't know, Leetcode just been doing more and more difficult, or like not difficult problems, but problems with complex algorithms, and I'm trying to think about a easier, simple algorithm way of doing it, but that just, you know. But yeah, and I end up spending too long trying to figure out which way to do it, even though I know like the 3 or 4 ways to do it in my head. Anyway, yeah. So the way that you may do it this way is that, okay, well, the sum of the entire array, we want it to be divisible by p, right? Another way to write divisible by p is that if you have the sum of this is equal to some number 0 mod p, right? Technically, this is the notation is not quite this. The notation is like under p, right? You want to call it that way, right? Something like that. Right? But how you do it is that, you know, some of it, the sum of this would be equal to some number. Let's just say k mod p. So then now we're trying to find out some subarray, the smallest subarray, in fact, where we can subtract out that k minus p, right? Because, oh sorry, k mod p, not minus p, right? For example, if you have yeah, for this example, if you have, say, let me rewrite this real quick, hang on. And this is a little bit of, I guess, number theory, but it's elementary number theory, and it's something that does come up a lot on Leetcode and competitive, so I do expect y'all to practice it if you're not quite 100% following. That said, it is something that is, if you're a beginner, you might not know what I'm talking about, and that's probably true, because there's just a lot of like random facts and factoids with mods and divisibility and stuff like that that I definitely take for granted, but and I don't even know if they're super useful for interviews, honestly. I feel like, and I don't know if it's just me being lucky or whatever, but I feel like I don't know that many instances of like hardcore divisibility things, right? But anyway, but yeah, so let's say you have, you know, a sub, writing it out, a sub 0 plus a sub 1 plus a sub 2 plus a dot 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 plus a sub n, I guess technically n minus 1, but I'll just write n. It's equal to some, or this mod p. Oh, whoops, why did I write mod p on the other side? Yeah. It's equal to some k, right? And then now, so then we want to subtract out some subarray, the smaller subarray, where, I don't know, let's say a sub I plus dot 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 a sub j is also equal to k, this mod p. So then when you subtract this out, you know, something in the middle cancels out, and then now you have the rest of the array is equal to 0, or the rest of the array mod p is equal to 0. That's really basically the idea. And then, so that's the math behind the idea, right? Well, what do you do with this idea? N is 10 to the 5th, so you're not going to be able to do like n squared type thing of like try every sub-array. So what you can do though is this idea of prefix sum, right? What is the idea of prefix sum? Well, the idea of prefix sum is that, let me erase this top part real quick. The idea of this prefix sum is that, okay, let's say we are at a certain here, right? Then now, let's say we're at a sub j, right? Oops, why did I write my j so weird? I think I was trying to write an I and I got confused. Then now we want to go, okay, well now, given that we're a sub j, we want to know that that plus some a sub I previously is equal, this mod p is equal to k, right? And in a prefix sum kind of way, then now you this subarray sum is going to be equal to, and I know I'm not going to go into prefix sum too deeply, but definitely like prefix sum is a prerequisite for this problem clearly, or at least the way that I'm doing it. Maybe there are definitely other ways to you could do it without it, I think, but maybe I'm wrong. I don't know. Yeah, so prefix sum, you have something like this plus dot dot dot, right? Plus a sub j minus a sub 0 plus a sub 1 plus a sub 2 plus dot 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 a sub I minus 1, right? Yeah, and then when you kind of line them up, everything before cancels out, so you have a sub I plus dot 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 plus a sub j, right? So that's really the idea behind prefix sum. And then here, then now, if you do the math again, we want this part to be, mod p is equal to k. So that means that the rest of this part, the part that we delete, has to be mod p has to be equal to p minus k, right? Sorry, I was getting a little confused for a second. P minus k. roughly speaking. I say roughly speaking because if k is 0, for example, then, you know, but let's just say it's this minus mod p, right? So that's really the idea. And doing all these maths, you're able to kind of get the latest index in which these are true. And after that, you should be able to get the answer. And honestly, I think the way that I did it here is not very intuitive or easy. Or even medium, really. I think this is a little bit harder. Maybe there is a dumber way. But oh yeah, I think I complicated things a little bit too much as well, right? Because here we have also, but you know, that is the general idea, right? Yeah. So total is equal to sum of nums, right? Let's say n is equal to n of nums. So then that means that what we're targeting, right, is that we so the total for the entire array is going to be this. So we're trying to remove. So total mod p is going to be equal to the k that we're talking about a lot, right? So let's maybe even say k is equal to this thing, right? So then if k is equal to 0, then we're already done. So then we return 0, just so that we don't have to handle it. But otherwise, then now we're for each index, right? We're trying to figure out, okay, how far do we go back to delete in the best way, right? So, okay, so best is equal to n minus 1. Oh, actually, I guess n. So then we can do, if best is equal to n, we can return -1 because it's not possible. Otherwise, we return best at the end, right? And then here we have for I in range of n, which is, and this is brute force on this dimension. We have to be small in the other dimension, otherwise it's going to be n squared, but brute force in this dimension, right? And actually, I'm going to write out what the brute force might look like, the actual n squared brute force, to kind of visualize a little bit better in code what I'm talking about, right? So here, for I is that, okay, num sub I is the right index of the subarray we're removing. What is the left index, or the, and also here the left index we want it to be, we want left index to be as high as possible, right? Because the higher it is, the smaller the subarray is, right? So we can maybe, let's just say, then for left is in range from 0 to right. Yeah, I guess we should do it this way, right? So we're inclusive. So then now we have this. The way that I did this a little bit funky. Actually, I'm going to rewrite this a little bit from right to 0, right? So it's counting down. So then now we can say subarray sum is equal to 0, right? And then here, sum we added by num sub left. This is inclusive, right, of left and right. And then now if subarray sum mod p is equal to k, and because that means that removing this will take k out of the total, then that means that this is a possible answer. So then best is equal to min of best, or right minus left plus 1, right? And this should be good. I mean, it's going to be too slow, like I said, because it's n squared. And yeah, I mean, you know, and it will definitely time out if we try to submit it, right? Because n squared is way too slow. So then now the question is, okay, we have this n squared solution. We have Larry wanting to drink a tea. And then, so then the idea is that, okay, how can we figure out how do we figure out how to optimize for this, right? And the answer is with prefix sum, as we talked about, right? Basically here, right? Okay, I mean, we'll do the formulas in a sec, but actually, I mean, I guess in a sec, I mean now, right? Because basically we have num in comments, we have num plus or num sub sum left plus num sub left plus 1 plus dot 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 plus num sub right. Is we want this mod p is equal to k where for the same reason that we have it here, right? And left should be as close to right as possible. We could talk about that part. We can talk about, but yeah. So that means that if this is equal to k, right, and then we can rewrite this a little bit, you know, and maybe technically mod p on both sides. So we just assume this mod p on both sides. We know what num sub right is in this case. We don't know what num sub left is, or left rather. We don't know what left is, but we know what right is. So we can, yeah, take this out, right? So then now we subtract num sub right on both sides. So then you have the same thing so far, plus dot 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 plus num sub right minus 1, I think. And it's gonna be mod p on both sides, but yeah, num sub right? So then now this is the number that we care about, mod p, right? And right, but in a prefix sum kind of way, what does this mean, right? Well, in a prefix, and this is a lot of math actually, maybe there's an easier way, honestly. In a prefix sum, we know that we have some num sub 0 plus num sub 1, oops, plus num sub 2, oops, plus dot 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 plus this thing is equal to that, you know, some number, right? I just say x, and the reason why I'm using x is because this is something that we can calculate as we go, right? So we actually know, we know x as well, we know right, and we know, and as a result of knowing prefix sum, we know what this is, we know what this is, and we store what all this stuff is in general, right? So dot dot dot, right? Dot 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 here. So then now, actually maybe I lied on this one. Maybe this one is a little bit bad. Sorry, unnecessary. My apologies. I am doing this live, so, and I do not know the problem ahead of time. So you know, it is what it is. But this is, part of me I don't know. Part of me thinks that I'm complicated way too much, but it is still a good foundation for similar problems, even if maybe for this particular problem there's a easier solution. I think the other idea is that, anyway, we'll talk about other ideas afterwards. But yeah, so then now we have this thing, right, which we know, and we know that we want this part to be k mod p. So then now, if we subtract this part, assuming that it is k mod p, then you have dot num sub left minus 1 is equal to x minus k, right, mod p. And I think that's it, right? I didn't write it out this time though. So okay, so to go over it again, so we have this number which we can calculate as on a prefix kind of way. We're trying to figure out this number so that, and if we, excuse me, if we subtract, I don't know why I say it so weird. If you subtract this from this, and they're all mod p, right? Then this is what you get, right? Yeah. So that's really what the only thing that I'm doing is that, yeah, this prefix sum gives me this number. We know we want this number to be this number. Everything's under mod p. So then we can just subtract this from this, and you get, you know, x minus k on the right side, and then everything here cancels out on the up here. So then it's just left of it, which is how you get this number, right? And in the case that there are multiple index, we just choose the left that is closest to the right, which means the last time you've seen this number. So that's really the idea. So here we have prefix sum, we have prefix of 0 is always going to be either 0 or -1, depending on how your notation is. But yeah, and then now you have a prefix total is equal to 0. This is what I call x. And here we have prefix total, we add it to num sub right. And then now we know that we want to find a k, so then we have prefix total minus k mod p, right? So this we're going to find it in lookup, right? So this is the target. If target is in lookup, then we're good. Then lookup of target is going to be the index that contains yeah, it should be the maybe I'm off by 1 anyway, but yeah, this should be the index that contains the prefix, which is left -1, I think. So then now that means that if you want to call it this, either this or this plus 1, I have to be a little bit, I have to check again. But yeah, and then now we can do max is equal to min, best right minus left plus 1, and then that's it. And then after that we look up, we update lookup with prefix from to right for the current index. That's pretty much it. I mean, it might not be 100% right because like I said, maybe very easy to do off by once. 0, 0. Oh. I think I'm off by 1 on the index though. I think we can actually do this for -1. It's fine. Okay. So why is this wrong? Dun dun dun. The fun part of debugging. I mean 0, this is good, but then that's just this if statement, so of course it's going to be good. I put -1 here. They don't have a -1 answer actually, so that's actually weird, but we can move 5, 2 to get 9, so okay. This is 9 minus k, what is k? K is 7. Am I doing the math wrong? It's possible, honestly. Oh yeah, what am I doing? I was trying to remove the prefix, that doesn't make sense. Okay, so 2, right, we have 17, or 16. 16 minus, well, 16, so target is going to be 0. Did I do this math wrong? That doesn't make sense. K is... Well, actually it makes sense, but it's not the only place, right? Yeah, okay, yeah, no, that should be... Yeah, no, okay, no, it makes sense, because I do update it afterwards. But I don't know why this is doing -1. Unless my math is wrong and I'm just removing all the numbers. But, I mean, sometimes we make mistakes, but the idea, I feel like I feel like recently my math has been okay and my algorithm's been okay, but my implementation's been bad. So I don't know. Let's take a look here. Separate 4, left, right. Maybe the left. Oh yeah, I did say that this was going to be this +1, but I think I just forgot to actually put it in. Okay. Because then now 0, 1. 0, 1 doesn't make sense though. Right. It's 10. No, this makes sense. You can remove 3 and 1 because it's inclusive. Okay, no, this makes sense. I think I just missed this case, or I don't know, did the indexing well. But then here we have 03. Why? Because we don't update. Oh, I'm dumb. I update the prefix total, but this has to be mod K or mod P. Well, I think I just actually meant this as prefix total mod P anyway. That's why. I was like, I don't get why it's skipping things, but in my mind I did it. That's why I'm a little bit sloppy. And I talked about, you know, now am I ready? I want to get a case at least where we do a -1 for sure. So maybe we have 1, 2, 3, 4, 5. We want P is equal to, I don't know, 8. I think you get 8 maybe. What is a, I don't know, 5 and 10. I think that's a -1. Yeah, okay. Let's give it a quick submit. Hopefully this is right. Oh, I was gonna say, apparently I got wrong answer twice last time, so this is gonna happen again. Another 4-year problem. But yeah, I would say, even though, like, this is the thing, right? Is that with all that explanation, if you look at just this code, it looks easy, right? It's like, oh, okay, of course, maybe. It's just 20 lines of code. How hard can it be? But then, you know, we go over all the math, and that's really how to come up with it. The idea behind, so there are a couple of things that I kind of skim over. This is just basically saying that, okay, well, this is the target. We have a lookup table, and lookup contains the index of the left boundary, right? So that's basically what we have here. And the reason why we update it is because here if the two numbers of the prefix total of the same tiebreaker, and here after we mod P correctly this time, if there's a tiebreaker, how do we want to handle it? Well, we want to handle it by choosing the one that's the latest, and the one that's latest is going to be the current one, right? So that's why we update it and overwrite it, right? There are other similar subarray problems where, for example, if you want to find the longest, well, if you want to find the longest, then you find the first instance of it, and then every time that, yeah, and that's it, right? And then you don't update it ever if it exists. That's really the idea. I'm curious how I did last time, so let me take a look. Yeah, I guess I did it basically the same way. But hopefully today's explanation is a little bit better. Yeah, and what's the complexity, right? Well, this is going to be linear time. You have to read every number. And linear space due to this number can really be linear. Numbers can go up to 10 to the 9, right? So, and P as well. So definitely it can be as many as elements as you have. That's all I have with this one. Let me know what you think. Thanks for watching. Have a great rest of the week, everybody. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.